Yeah. Hi everyone. Today I'm talking about RAG evaluation framework. I'm Ibrahim Al Azhar, PhD student in Computer Science Department in NIU. So, at first, the first of the couple of slides, it will be the introduction to RAG. What is the RAG and how it works? Those things. So, at first, what is RAG? So, the full form of RAG is Retrieval Augmented Generation. So, it's an AI framework which enhances the LLM output incorporating external knowledge. So, basically RAG has two components. First one is retrieval and second one is generator. So, at first the user asks some questions and retriever the component retriever collects the question and it collects the some information from the external context. So, it can be any other vector database or any other website or anything, and it integrates those information from the external vector database and send to the large language model, and then large language model incorporate the questions and external information from the context and then generate a response. So, in RAG, there are query processing, input query process and converted to embedding. There are retrieval. There are augmented input. Augmented input is the query and the text from the external context, and the response generation. Response generation is from LLM, large language models. So, introduction. So, RAG incorporates capabilities of LLM and information retrieval system. So, basically LLM has some problem. It relies on parametric knowledge. So, what is parametric knowledge? Parametric knowledge is LLM mostly relies on the information which stores in this parameter. So, maybe LLM is not updated, LLM is not aware of the recent information. So, RAG overcome those problems. So, basically there are three type of RAGs in the broader category. So, first one is naive RAG, second one is advanced RAG, and third one is modular RAG. So, here I will be talking about just two type of things, the naive RAG and advanced RAG. So, naive RAG is the pretty much basic thing. It's just a simple retrieval system, and the vector database will be creating from chunking methods, and then any LLM incorporate with the retrieval system to get the better response. So, there are some problems in naive RAG. Naive RAG, maybe retrieval quality is low, maybe the extracted information or LLM generated information can be hallucinated, biased or toxic response. So, that is why to overcome those problems there are some more tuning of naive RAG and those called advanced RAG. So, advanced RAG people can optimize using sliding windows, because when we are sending some information to the LLM and LLM from the retriever system and query, so LLM has a context window. So, sometimes if it's the context window is smaller, then the input should not be input should be within the context frame. So, maybe sliding windows can be another approach. Another approach is fine grained segmentation, and maybe incorporating metadata to get the broader context. So, in advanced RAG, one of the primary concern is removing irrelevant information. So, after getting the information from the retrieval, there are some information which is not much relevant. So, the concern is remove the as much as irrelevant information. Another approach is incorporating graph approach in retriever system. So, here extracting system from the retriever is a very crucial part, because vector database contains so many informations, and we have to extract very much related information from the retriever that LLM can generate better good response. So, maybe graph approach can be applicable there in retriever system, where entities can be act as a node, and the relation between entities act as an edge, and then using the graph approach we can extract the very good information from the retrieval and send to the LLM. Another thing is adding metadata I mentioned earlier, and optimizing the index structure. Another thing is fine-tuning embedding. So, there is one popular approach called BGE. So, they fine-tuned the embedding model and then they got better response. and another is mixed retrieval. So nowadays this mix, there are so many works working on mixed retrieval system. It's like there are some retrieval system using embedding vector. Alongside that, people are using keyword based extracting information, semantic or vector search, like using both, like using embedding based, also keyword based, that we can get better information from the retrieval. And another thing is post retrieval process. So it's like after getting the information from the retrieval, it can be like the text, retrieved text can be re-ranked, like the more important text is in first rank and second, third rank. Another is prompt compression. This is also very interesting thing. Prompt compression is, suppose we are using Llama model, and Llama has suppose, for example, 16K context window. So it can't take more than 16K tokens as an input. So we can compress the prompt. So what is prompt? Prompt is the retrieved text from the vector database and input query. So we can compress the prompt to the LLM, then LLM can generate better answer. And another is hierarchical tree and decompose and compress approach. So those approaches like nowadays very popular to achieve the better result in RAG system. So why RAG? So there are some advantage to using RAG. At first, LLMs know a lot, but not everything, because LLM can't know everything. There are so many information in some downstream area, maybe healthcare or some other maybe politics or something. So RAG can be a very good approach to get better information from those downstream tasks. Another is retrieval grounds the answer in evidence. RAG prepends freshly retrieved passes to the prompt, letting the LLM copy or reason over source text and reduce hallucination. So RAG can be applicable for reduce the hallucination of LLM. Another is, and one more thing is 2 modules, 2 failure points. What does that mean? It is a great retriever plus a sloppy generator still yields a poor output. We must score each component separately and understand how they interact. So this is the thing is, we have 2 components. One is retriever and another is generator. So we have to we have to concern about the information we are getting from retriever and generator. Otherwise, if anyone fails, maybe retriever or generator fails, then the output is not good. One more thing is continuous benchmarking keeps system healthy. So yeah. So how RAG overcome LLM's problem? So like in earlier slide I mentioned that RAG augments external knowledge, which allowing up to date information. It retrieves relevant passages to provide additional context for long context tasks, because like if the context is very long, then LLM, there is one paper, very famous paper called Lost in a Middle. So like LLM does not provide that much importance in the middle text. So that's why if there are some context, like long context, then LLM do struggle to get the to synthesize the information. So another thing is citation generation. Still LLM is not good for generating citation. It generates fake citations or fake paper and something. So RAG can be a good approach to overcome those problems. And LLM do like answer some generic answer. So one famous thing is like if you upload a paper and ask that, okay, review this paper or something like that, LLM always says that generalizability problem and something generic answer. You can get that, okay, this is the answer is like for all paper. So RAG can be incorporated to get the specific information. And for niche topics like healthcare or politics or some other niche topics, RAG can be a good approach to apply, and for concise answer as well. So variants. So in terms of architecture, RAG can be variant in 3 category, in a 3 broader category. First one is query based retrieval. This is single step. So what is query based retrieval? This is a like just a very simple thing. We can say that this query based retrieval is same thing as naive RAG. So it's like we have a query, we have a retrieval, and then we are getting information from a single query. That's it. And we are sending those retrieved information to the LLM and that's it. This is a query-based retrieval. So another thing is iterative retrieval, and this is a very, very promising area. People are working on it, and this performs in a very good way. So what is iterative retrieval? It's called multi-step. So suppose I have a query and I have a retrieval system. I am retrieving the data, and then I am re-ranking the data. Like okay, this is the first one, this is the second one, this is the third one, and I am checking okay whether the retrieved data is good or not. If it's not, then I am retrieving data again. It's like iterative, like something like we are using loop or something like that. First iteration we are not getting good data. Okay, go back and then again extract data, something like that. And this can be this can be defined by LLM. Like after getting information from first iteration information from the retrieval, maybe this can be defined by LLM, and then maybe we can go for second iteration. You can say that's something similar with self feedback and recursive retrieval. So this is two things. Another variant is latent augmentation. So in latent augmentation, it's using embedding or hidden state. There are no straightforward textual query. There are some embedding or hidden state, and those embedding or hidden state goes to the retrieval, and then based on the cosine similarity, getting information and sent to LLM. This is three type of variants in terms of architecture. In terms of application, there are so many variants.
So for the first one, you just, for example, retrieve the top K documents, and you ask the large language model, here are the top K documents I retrieved from the dataset or from the search engine. Can you answer the following question based on the top K documents I provide to you? Is that how it works?
Yeah.
And for the second one, after you find top K documents, you tell the large language model, okay, those are the top K documents I already got. Do you think they are good? If they are good, can you generate the results according to those documents? If they are not, I will do the search again.
Yeah, so this is one approach, like refining by LLM, that can be applicable. Another very famous paper is called self-reg. So in self-reg, they are not using LLM for refining. They are using their self tokens. So it's like I have to go through the paper again. So basically, yeah, at some point they are using GPT-4 for judgment, but for self-reg, they are it's like evaluating their tokens in like self token, something like that.
And for the third category, how it is possible, for example, if we are using a search engine for providing the documents, in order to use the latent representation for doing the reg, you need to generate the latent representation for all the documents on the internet or in their database, right?
You mean vector database?
Yeah.
Yeah. So for
how that could be possible, right? For example, if within OpenAI, if they want to utilize this method, they need to encode all the possible documents on the internet, such that you can use the embedding to find the top K documents according to the similarity of the embeddings. Right?
Okay. Yeah, I think so.
Is that the shortage of this method?
Sorry?
Is that the shortage of this method?
I'm not aware about this third one. I found in survey paper. I have to go through again, like how it works, latent augmentation stuff.
Which one is the most commonly used one?
I think the second one, iterative retrieval, is more popular. It's like refining and then getting data from vector database.
Do we know what is the method that is utilized in some of the commercial large language models, like the Cloud or the ChatGPT? What is the method they are using?
So I do believe they are internally using RAG method. Like there are multiple agents, and if I ask some questions, we can see that in GPT that searching the web and something like that. But those closed LLM, I think so they don't publish anything, the architecture, like how the LLM integrated or something. Like they don't publish anything. Like, but I do believe they integrated LLM agents and RAG in their systems. Yeah. So for the variants, there are lots of tasks. I'm just like mentioning the 3 popular tasks. It's like most of the time like evaluating the benchmark, like a QA, question answer summarization, and any type of knowledge intensive tasks. And as I mentioned earlier, the component is 2 primary component. One is retriever, another is generator. So a retrieval can be sparse or dense or hybrid retrieval, and generator is like, it's like you can use any LLM. So now I'll be talking about a little bit in retriever system. So for the retrieval system, it's like a retrieve the information from the vector database. So one approach can be is like lexical matching techniques. It's like a more you can say that like a sparse retrieval system. Like it relies on surface level term matching. You can say that something about term or keyword matching from the query to the vector database. So example is BM25 or TF-IDF is a very much pretty old approach. So the good thing is it's very fast because it's just a term matching thing. The cons is like it does not capture the semantic similarity because it's just like a term matching, and there are some problem from lexical gap. So there is another approach. It's called contextual and knowledge aware retrieval. This is more about like linking or graph based multi-hop, multi-granularity system. So this is like knowledge aware retrieval system. And another popular thing is dense retrieval. This is more about like using neural network, and which is encode the queries, and then based on the queries, then get the information from the retrieval system. And then BM25 BART, by encoders, cross encoders, those are using for dense retrieval, and this is very popular nowadays. So this is a little bit RAG timeline, like how RAG evolves over time. So we can see that in 2020, the first RAG, like from Facebook, I think they mentioned that, but this time LLM was not popular. They had mentioned that okay, like that time I think BART model was popular, not GPT or something. So they mentioned that okay, RAG can be useful and something like that. But people are not working that much. But after publishing ChatGPT 2023, we can see that there are so many models are coming, and then people are using RAG very heavily because it can solve there are so many problems of LLM. So yeah, so there are some models. It's like it's mostly pre-training based. It's like a pre-trained model. There are some RAG models which is fine-tuning model, and there are some RAG model which is mostly inference based. So this is the RAG compared with other optimizations. So in terms of optimization, we can say that in the x-axis it's like a model adaptation required, how much adaptation requires, and the y-axis is like how much external knowledge required. So in like earlier slides, I mentioned that there are 3 types of RAG: naive RAG, advanced RAG, and modular RAG. So it starts from the lower part. It's called prompt engineering attempts. So here it's like a very small adaptation required, as well as in prompt engineering, it's like we are providing very small external knowledge. It's like just in context learning. It's prompt engineering, and then on the top of that, there are adding few short case chain of thoughts. So if you provide like think step by step or any chain of thought stuff like that, it improves better. But still, it's like we are not providing that much of external knowledge. But if you go a little bit upper side, like naive RAG, it's like a very small vector database. Advanced RAG, it's like a index, pre-retrieval, post-retrieval optimizations, and then modular RAG, it's like organic combinations of multiple models. This is the like main 3 structure of RAG, and on the right side there are all of the above. It's like a we can do fine tuning of retriever, we can do collaborative fine tuning, generator fine tuning. So these things, it's like it requires mode adaptation. So in terms of RAG taxonomy, RAG core techniques, there are 4 steps. First one is a pre-retrieval system. another is retrieval, another is post-retrieval, and last one is generation. So what is pre-retrieval? Pre-retrieval is at first start with indexing. Like there are a bunch of models which is for indexing the data, and then query manipulation. So suppose I have a query, I have some questions I want to ask to, like I want to send to this query to reg. So we can manipulate the query. We can do like make a better query. And third one is data modification. We can modify the data. And this is pre-retrieval. It's like we are not retrieving anything. Before we are sending our text to the retrieval system, we are doing some pre-processing to make our query better. So second one is retrieval. Retrieval is we are retrieving data from the vector database. So one thing is search and ranking. So after we are sending the query, retrieval system search the information from the vector database, and then it will re-rank, like ranking mechanism. And here there is called iterative refinement can be work, and this is for retrieval, search and ranking, and there are a bunch of works already done for this thing. Another is post retrieval. So this is for after getting the information from the vector database, we are doing some post retrieval like re-ranking. After getting ranking, okay, I don't like this rank, I want to re-rank those data. So we are doing re-ranking, and we can do filtering, like based on the tags, we can remove some data. We can do some re-ranking again. And last one is generation. Okay, after we are getting all of the data from the vector database. So now we want to generate the data from LLM. We can do enhancing. We can do customization. So this is a diagram for how information retrieval can be done using LLM. So okay, I'll go this slide little bit later. Okay, so this is for interactive retrieval strategy. This is more about iterative refinement. So I'll be starting from the top. So this is called data modification. So this is source corpus. It's like we can think about this is a vector database. We have a bunch of data, and we are like it's expanding the data and summarizing. So we are making two things, and then after that we are making chunks. Like the vector database creating some chunks, and then we are doing embedding. So this is the first one is it's for like how we are regulating our vector database. So second one is query manipulation. So query manipulation is it starts with user query, and then we are doing same thing, expand and reformulation, and then it creates some embedding, and then after getting the embedding from the query, and we also already made the embedding of the source corpus like vector database. Now we are matching the similarity. Like okay, what is the embedding of the user query, and what is the embedding of the source corpus like vector database, and we are matching the similarity like cosine similarity of each chunk, and then we are start like this is the right side similarity match, and then this starts the filter, like this is the similarity match, and this starts filtering. Like for filtering, suppose like chunk 3 is not important or something like that, remove, and then we are re-ranking. Like so, suppose chunk 3 is not important or not good enough, so we are doing re-rank again, and then we are checking the threshold. Like okay, the rank we got, the retrieval information we got, whether it is up to the mark or not. If it's not up to the mark, we are doing re-ranking again. That phase we are doing re-ranking again, and we are doing same approach again. Like it's called iterative thing. Like at first we are doing the ranking system from the user query and source corpus, and we are going through all over the system, and if it's not past the threshold, we are repeat the same process. And then after that, if it's good, then it goes to the LLM generator, and then this is the LLM generator, and we are generating some informations. This is called interactive retrieval strategy. Yeah.
So what is the purpose of expand in first two steps?
Expand and summarize, I think it's for broader context. Suppose like I have a source corpus, so maybe I can expand like maybe I can make two separate things. One is I am expanding the data, and another is I am summarizing the data.
Why expanding or reducing?
I think it improves the performance. It improves the retrieval quality. We are providing like more context, like we are providing the summarized dense context and broader context.
So expanding is done by LLM or by the human?
This part I'm not sure. It can be done by maybe LLM or something. Yeah. Yeah, I think so. It can be done by LLM also. Yeah. So this is the RAG taxonomy. Though we have two components, retriever and generator, and third one is we can say that augmentation method, because the the retrieve text from the retriever, like vector database, is very important. The like how generator works is very important, but another important thing is how we are combining retriever with generator. Suppose like we are getting some data from retriever vector database, whether is it good for generator or not. So this is called augmentation methodology. So there is one famous paper from, I think, Google, like Ask to Drag. They mentioned that sometimes the retrieved information may be harmful for LLM. So we have to check that, okay, whether the data we are providing to the LLM, maybe it harms LLM. So there are a bunch of works done in three categories. So for retrieval, there are some, for better semantic representation, it's like a chunk optimizations. So what is chunk optimization? It's like a, like suppose, normally we can create n number of chunks, right? So for each chunk, maybe we can set for 512 tokens or more than tokens. So we have to fix that how many chunks we need and what is the size of the chunk. And this is called chunk optimization. So and this varies task to task. So we have to fix out that, okay, for chunk optimization. And another thing is fine-tuning embedding model. So we can incorporate any fine-tuning embedding model in chunks to get the better result. Another thing is align queries and documents. So it's like query rewrite and clarification, embedding transformation. And another is align retriever and LLM, plugin adapter, LLM supervised thing. Yeah, and then augmentation study, there are pre-training, fine-tuning, inference. Yeah, it's like, so last, then in the augmentation process, there are some once retrieval, iterative retrieval, adaptive retrieval, we mentioned earlier slides. Okay, so this is like, it's about mostly how RAG works and how we can make RAG better and stuff. So now we are talking about RAG evaluation. So how we can evaluate the RAG system. So the evaluation pipeline is like start with index, like, and then search, prompt, inference. So indexing can be sparse or dense or hybrid. Search returns stopgap chunks that fed an LLM prompt. The LLM generates the final answer. So this is like whole process. So the evaluate output. So output is like there are two type of, like majority there are two type of output. One is like we are getting output from the retrieved context. It's like a vector database. And another is like we are getting some information from the LLM generator. So we are getting two type of outputs. One is from vector database, another is LLM generator. And possible ground truth is like human written answer or some gold passages. They have some curated labels where ground truth exists. Also, it's also possible that there are some system, this is like reference free, like there are no ground truth. So in this case, like reference based, whether they have ground truth, and reference free, they don't have ground truth, we can evaluate the RAG system. I'll show in next slides. Okay, so in evaluation pipeline, there are a bunch of components. So each component we can evaluate. So it starts with query. So query is like the question. So we can evaluate query with retrieved documents. So what is retrieved documents? Retrieved documents is we are getting some data from the vector database. So we can compare whether the data we are getting from the retrieved documents is compatible with our query or not. So this is one evaluation thing. Second is query with LLM generated response. So query is like the first question we are sending, and LLM generated response is after getting the data from retrieved documents, we are sending to LLM. LLM generates some response. Now we are comparing whether this query, like this question, is compatible with LLM generated response or not. This is second thing. Third thing is retrieve documents with vector database. So it's like a vector database is like we have a big number of chunks and stuff, and we are like based on the query we get some documents. We get some documents. So now we are checking that the retrieved documents and the vector database, whether how much good like valuable information we extracted from the vector database. Fourth one is retrieve documents with LLM generated text. After retrieving the documents, we are comparing with the so this retrieved document is input of the LLM, right? So we are comparing input with output, like whether the input is good or not, or whether this providing this input improves the LLM performance or not. And last one is the query, the question, and the final LLM generated text, both are compatible or not. Yeah, those are the like bunch of evaluation system for RAG. Yeah, so this is like another diagram for RAG evaluation system diagram. I'll go through this slide little bit later. I'll go this slide first. So this is one paper. They showed that. So suppose the left one, the red one, those are the results, like relevant docs, responses, output. The right one, those are the ground truth. Docs candidates, sample response, and label. So what is docs candidate? We can say that docs candidate is the vector database, right? There are some like sample response. So sample response is the input of the LLM, and label is if there are some labeling data, there are some label. So in the left side the result relevant docs. So relevant docs is we are getting some information from the vector database. This is result, and ground truth is vector database itself. This is one like evaluation system. The second one is we are getting some response from the sample response. That means we are getting response from LLM generator. This is our result, and we are providing some data to the LLM generator. This is our ground truth. So this can be another called evaluation system. And in earlier slide I show that we can be evaluating each system with query. So they mentioned that a relevant docs with query, it's called relevance. Next one is accuracy, relevance, faithfulness, correctness. Yeah. Yeah, so there are a bunch of works done in RAG evaluation system. So popular one is RAGAS. So RAGAS is quality of RAG system. So in quality of RAG system, the methods is context relevance, answer relevance, faithfulness. So in later slide, I will show how those can be measured. The metrics is like extracted sentence divided by total sentences, average cosine similarity, supported statement, total statement stuffs. Another evaluation strategy is called ARES. So it's a little bit improving of RAGAS system. So it's like they are taking whole system from RAGAS, but they are providing confidence intervals, like how much confidence those data and something. Third one is recall. This is called counterfactual robustness. So this is like more counterfactual thing, and the method is response quality and robustness, and the metrics are like pretty much common thing: blue, RAGL, misleading rate, mistake representation rate, and stuff. Another is RGB. It is impact of RAG on LLMs. So method is noise robustness, negative rejection, information integration, counterfactual robustness. Another is MyReg, it's for medical data, and they are using zero-shot learning, multi-choice evaluation stuff, EREG and Bargain. Okay, so those are the bunch of the works done. Okay, so now I'll be talking about what type of metrics we can use for the evaluation system, because I'm talking about the textual thing. So we can use any of the traditional NLP metrics for evaluation. Suppose BLUE, RAG, METEOR, BART score, cosine similarity, Jaccard similarity, pointers mutual, something, NMI, F1 score, anything. This is one thing. Another thing is we can use LLM as a judge. So every retrieval text, every generated text, we can use LLM and we can measure grammatically, readability, cohesiveness, understandability, those things with reference free, with reference based both. So if we have reference, like if we have ground truth, we can send the extracted or generated text to the ground truth, like ground truth and generated text both to the LLM, and we can measure those things. If it's not it's not reference, if there does not have reference, we can measure the grammatical readability and cohesiveness, like reference free system. And we can also do human judgment here. So additional metrics. So there are some more metrics. It's called misleading rate, mistake reappearance rate, error detection rate, latency, diversity, noise robustness, negative rejection, counterfactual robustness. Those metrics is more applicable for retrieval system. So in retrieval system, we are retrieving the data, but we can measure that, okay, what is the misleading rate, what is the mistake reappearance rate, something like that. Yeah, those things. We can improve the RAG system, RAG evaluation system with RLHF, RLAIF, with GPO, PPO, with LLM. We can do fine-tuning LLM generator to make a better evaluation system. Also, we can do some post-training, or we can do something in inference time, like chain of thoughts or self-consistency. So earlier I talked about there are two types of things, reference-based and reference-free. So reference-based is we can use anything about n-gram, anything about embedding-based model. And in reference-free, suppose like we don't have ground truth, we can do, there are some good work, like one is called quality, like in quality-based metrics, RAG-C, super. So super is used for BART for generation pseudo references. They are using BART and they are making some pseudo references because those data does not have any reference, and then they are generating quality of generated context. And another is called entailment based. So it's like whether the output context, whether generated context contradicts, entails, or undermines the given text. Suppose like I'm sending some data to the LLM, and then LLM generates some data. We got some data. So now we can measure that whether the output context, generated context, contradicts with the given text or not. So here given text can be the any information, or we can use LLM to generate some more like contradictory information, and we can measure that the output information contradicts the information or not. And we can measure factuality, QA, QG based, like evaluate whether generated text contains interactive information compared to source text, like example, those things.
So if it is a reference free, then what is happening in the entanglement based on factuality, because they have to check whether the context contradicts with something, right?
Yeah, so it's a very good question. I'll be talking it later, but I'm replying this question. Okay, so the thing is, suppose I have a query, right? So I have a query, and then I'm sending this query to the retriever system, and retriever system like from the retriever system I get some response, right? So now, so though like vector database can act as a ground truth, but if you want to do something reference free, what we can do is like, so I have a query and I am getting some extracted information from the retrieval system. So now there is some questions, like suppose who is the Prime Minister of US, and there are some information I got from the retrieval system. So now we can make some questions using LLM of the retrieved text. So retrieved text is like blah blah blah, something like that. Suppose suppose we are getting 5 more questions from the retrieved text. So now we can measure each the embedding of each retrieved each LLM made questions with the query.
So by reference free, you mean that there will be no pre-reference, right?
Yeah.
It will be on the process.
Yeah.
LLM generated.
Yeah. So the process I told, it's for, they use this approach for Regis approach. I'll be talking in next slide, I think. So yeah, so there are a bunch of things. If someone wants to do reference based, suppose I'm not I can't rely my reference or something, then there are some process we can do.
So, how do you know that the questions that is generated by LLM?
Is good or not?
Yeah.
Yeah, this is another question. I don't think so. They evaluate this process. They mostly evaluated the questions from LLM and the original query, and then just match the cosine similarity of embedding something. But this is another question.
Consistent or not?
Yeah. So for the metrics, for the retrieve performance, those metrics can be used: precision recall, mean reciprocal rank, normalized discount cumulative gain. So those things is like we are retrieve some information from the retrieval, and then we are measuring, like for in vector database, this is a reference, and we are measuring some precision recall or something like that. This is more about reference based. So we can measure the generation quality, blue, RAG, meteor, BART score in terms of the retrieve text. So retrieve text is the input of the generated LLM generation, and we can measure those generation quality, and we can measure the faithfulness, factuality, relevance, coherence, efficiency, and scalability.
Let's assume I have a question. My question is, if I purchase a item from China now, what will be the total cost? I mean, for example, the cost, the price of the item is $100 with the current tariff that the United States is applying to China's goods. What is the final cost on my end? I assume this is a very good example of using RAG, because none of the large language models are trained with the data of those tariff numbers, right? So it has to use the RAG. And I assume it needs to collect information about the latest announcements from the White House. It needs to collect data from the shipping services, for example, from DHL. What is the latest clearance cost for the items you purchase and shipped through DHL? It may need to collect other information. But for this kind of questions, how you can evaluate the performance of the RAG?
Yeah, it's a very good question.
Yeah. I mean, this is a very good example of why we want to use RAG.
Yeah,
right?
yeah.
We want to use RAG not because we have a bunch of documents and we want to, instead of putting them into the training data to fine tune the model, we just want to feed them into the model for the answer for the questions you have.
Yeah, that's true.
The more realistic need is to solve those kind of problems that I just asked.
Yeah,
and
that's true.
In most cases, we don't have the documents in our end. We need to use the search engine to do the retrieval. We cannot even control the search engine.
Yeah. So in this case, I think in nowadays the closed large language models like OpenAI or Cloud or those things, they are more relied on the RAG system, because earlier time, I think they now do adding information, and they said that okay, ChatGPT is updated up to this day or something like that. But nowadays, it's mostly relied on the RAG system, and then we can get some pretty much decent information. So evaluation system is little bit challenging because it's searching the web surfaces and then collecting some data, like suppose some White House or something like that. So one evaluation system I'm thinking about, it can be doable for it's called mostly counterfactual thing. So suppose I get some there are some response, LLM generated response, and they said that those are the tariffs and those are the percentage or something like that. So one thing I think is using LLM, and then okay, so it's mostly reference. If we go for reference free, not reference based, then creating some questions. Yeah, but this still challenging, because we need some accurate information.
Most of the metrics you are describing here they are mainly for the scenario that you have the internal documents as the source you can search from, right?
Yeah.
And you have the ground truth labels for each of the question. What are the documents that should be provided by the RAG?
Yeah, that's true. Suppose the vector database is a one ground truth, and yeah. Yeah.
Question. So, I was wondering whether while we have a RAG,
Yeah.
we have the answer
Yeah.
for what we don't have answer maybe.
Yeah.
Maybe for one institution, the LLM doesn't have the information.
Yeah.
So we can easily put that information for that.
Hmm.
So given that LLM is trained on a vast amount of
Hmm.
data,
Hmm.
and we know that there are how it generates the text depends on that maybe when we ask the query,
Hmm.
there are some in the logics maybe the probability it is this token is if this token comes after this token.
Yeah.
It is there are
Autoregressive.
thing.
Yeah.
So when we add another external source RAG,
Yeah.
how much it impacts the original LLM trained data and how it becomes. I mean, I'm not. I just want.
I understand your point. Okay, I think I can answer your question. So you can think about RAG as in context learning. How you can in context learning. Suppose I am asking about the tariff questions regarding any products from China, right? So it search in a web and it gets some text from the any good sources, and then this is like more a number of sentences are incorporating with query. So now earlier maybe in query we have 10 tokens. So now we have 500 tokens, not 10 tokens, because we are getting more information from the other sources. And you can think about prompt. So these 500 tokens sends to the prompt, and then now based on these 500 tokens, and LLM has their own previous knowledge, and then it's generating some tokens in an autoregressive way. So based on this approach, it's totally in context learning. It does not impact anything about the LLM's parametric knowledge, or it does not impacts anything about like the existing knowledge of LLM. Like if fine tuning, and one concern is like sometimes LLM forgets what they actually trained on, because you are providing more information in LLM's parameter. But here you are providing like more in context learning, so LLM knows itself those things, and there are some extra information it collects from the prompt, and then it generates in autoregressive way.
Means RAG has in I mean the retrieve context has been the LLM's contribution in this part is to facilitate the text generation process.
Yeah, based on this context and their LLM's previous knowledge, just generating the text. Yeah. So so this is the metrics, pretty much popular metrics, but almost all of the metrics are mostly used for reference based evaluation. Suppose like precision recall, mean reciprocal rank, or blue rag for generation quality, or we can measure faithfulness, factuality, relevance, coherence, efficiency and scalability. So in relevance and coherence, we can use human evaluation, or we can use LLM as a judge, like Likert scale rating 1 to 5, or any GPT based scoring. For efficiency and scalability, we can measure latency, memory footprint, and throughput. So for the next, okay, I'll go this later. Okay, I'll talk this system first, RAGs. So this is I think pretty much popular, I think fast RAG based evaluation system. So there are three metrics, and how they measure faithfulness, answer relevance, and context relevance, those three things. So what is faithfulness? Faithfulness is LLM generate answer grounded in the retrieval context. So I'm repeating again, what is the retrieve context? Retrieve context is the text we got from the vector database. This is the retrieve context, and those retrieve contexts are sent to LLM to generate the answer. it's called LLM generated answer. So now the first matrix is faithfulness, measure the faithfulness. So LLM generated answer like should be grounded in retrieved context. So the way is like LLM extracts set of statements from LLM generate context, LLM verifies with RC. So they are using another LLM, and then suppose if I talk about the tariff from China thing, so it's like a LLM extract set of statement from LLM generate context. So LLM generate context, it says that this should be the tariff and something like that, and there are n number of texts. So now from n number of texts from LLM generated text, we are using LLM again and get like extract the single set of statements. Like this is statement A, this is statement B, this is statement C, something like that. And then we are using LLM again for measuring for verifying each statement of the LLM generated text and retrieved text. So retrieved text says that this is the information, something like that, and LLM generated text says that this is the information. So we are taking each statement from the LLM generated text and then checking with the retrieved text using LLM. This is called faithfulness. How faithful LLM generated text. Sorry. Okay. So next one is answer relevance. Answer relevance is LLM generated answer should address the actual question. So this is answer relevance. Suppose I am asking about who is the president of US, and if LLM generator says that Biden, it's not true, it's he is earlier president. So it's like LLM generated answer should address the actual question. How this can be evaluated? This is collected n potential questions from the LLM generated answers. It's like a LLM generated answer says that the current president is Biden. So now we are using LLM again and generating some n potential questions from LLM generated answer, and we are measuring embedding from the questions of the LLM generated answer with the actual query. Like we are measuring the embedding. This is called answer relevance. How relevance the answer of the LLM based on query. Third one is context relevance. So context relevance is retrieval context. It's like retrieved context. This comes from vector database, should contain focus and relevant information from the vector database. This is very important thing. Suppose I have a very big database. Suppose like I have a Wikipedia database. So I am collecting some information Wikipedia, but I am not sure whether retrieval collects relevant information or not. Maybe retrieval collects some garbage information. So we have to compare the result of retrieved context from the vector database and the information of the vector database itself. So this is called like their approach is little bit negative sampling. They use LLM and generated some false data in vector database, add to the vector database, and now they are measuring context relevance is extracted sentence divided by total number of sentences in CQ. Suppose like I have a 50 sentence in my vector database, I am creating 50 false sentences in vector database to a total 100, and I am getting 10 extracted sentences. So now I am measuring the context relevance using this ratio. So it's like given the query and retrieve context CQ to LLM, LLM extracts a subset of sentences from from retrieve context and answer the question. So it's like okay. So it's like I have a query. So I am asking some question, and I have a retrieve context from the vector database, and this retrieve context sends to LLM. Now I am using another LLM and extract a subset of sentences from the retrieve context, and then this subset of context like measure with the I think extracted sentence total number of sentences in CQ. Yeah. So now context relevant is the ratio of extracted sentence and total number of sentences in context. Yeah. So yeah, they show some score, and then it goes good score. And the good thing is like it's available in Pandas library. Anyone can use this one-liner evaluation system. It's pretty popular, and so where are you? Okay. Yeah. So Opera, a unified evaluation process. So for RAG evaluations, there is a survey paper, and in this survey paper, they proposed a unified evaluation process. So in this evaluation process, they said retrieval, relevance, accuracy, diversity, the generations like faithfulness, answer, relevance, and correctness, whole system extracts. It's like latency and hallucination rate. So it's like for retrieval, they measure the relevance, accuracy, and diversity. For the generation, LLM generation, they measure those things: faithfulness, answer, relevance, and correctness. And for whole system, the combination of retrieval and generation, they measure the latency and hallucination rate. And yeah, this is for this paper. And yeah, so now for the scoring retriever, those are the pretty much popular like call metrics in information retrieval system. Suppose like precision, recall K, MRR, and there are some like regex, they use some other approaches. For accuracy, it's like it measures the docs with candidates, which means the vector database and the extracted information. We can check hit at the K, negative rejection, those things, and we can measure the diversity and robustness, like coverage, misleading and error rates, those things. This is more about the in the retrieval process, like how our retrieve process is good. And for the scoring the generator, those things can be applicable, like regex applied the faithfulness, answer, relevance, correctness, and hallucination. And instead of this, we can use any text evaluation process. We can use anything about LLM as a judge. This can be applicable in the in measuring the performance of LLM generator. Yeah, so this is the LLM generator paradigm. This can be useful for measuring the performance of LLM generator, where the input context is the retrieved context and the output context is LLM generated context. So we can measure like fluency, relevancy, factuality, yeah, those things. And yeah, these are, I guess we already talked about it. And there are some framework. Those are the popular framework I showed in earlier slides. And there are some retriever focus and generator focus. Okay, so there are some open challenges, like judge alignment has some bias. And suppose like most of the time we are like in regex or some other papers, the measuring is mostly relied on the LLM. So maybe judge LLM has some bias. Suppose like in earlier seminar we showed that there are some verbosity bias or some positional bias, those things. So this can be one problem. And another thing is cost latency trends of it's like in regex we show that they are using LLM so many times, so maybe it raises the questions about the cost, because using LLM is always costly. And yeah, and another problem is if we don't have reference, then measuring the reg system is little bit tricky. So yeah, so key takeaways is like score separator and concord, score retrieval and generation independently and jointly. So it's like a there are three components: retriever, generator, and augmentation. So we can measure each component, and then we can do some average for evaluate the whole reg system. So another thing is we can blend the information retrieval and NLP metrics with LLM as a judge, because in regex paper they always they just relied on the LLM as a judge approach. So just 100% relied on LLM is not good thing in terms of cost or in terms of LLM bias. So sometimes it's good to use information retrieval and NLP metrics alongside the LLM. And feature work can be like we can work on the on proposing a good LLM reg evaluation framework, which can be less costly and which can be more fast and robust. Yeah, and yeah, any question? Yeah, sure.